Today we're going to continue our discussion of renewable energy, this time looking at hydrogen, wind, and water. So let's start by talking about hydrogen fuel cells. You may have heard of this before, water-powered cars. That's not exactly right. They're powered by something called a hydrogen fuel cell, which is more like a battery than a power source, except instead of running on a chemical reaction or like a battery does, it runs on hydrogen. The hydrogen is used to store energy. And the way it works is you've got this thing, which is a hydrogen fuel cell. It's got a couple chambers in it. On one side, you're injecting the hydrogen gas, which is the fuel source. The other side is atmospheric oxygen that gets injected. And as the hydrogen gets injected, it passes over this something called a proton exchange membrane. You don't need to know too much. Well, you actually do need to know a decent amount of detail about this. But as it passes across this membrane, it's going to get stripped of its electrons, and those electrons will flow through this electric current here, or they will flow through and generate an electric current. The flow of electrons is electricity. So the flow from the negative end to the positive end, the electrons will. Meanwhile, the leftover rest of the hydrogen atom, the proton, will react with the oxygen, chemically react with the oxygen to form water. So the byproduct is water. But it generates electricity as the electrons from hydrogen atoms flow from the negative to the positive, from the anode to the cathode, right? So you can see hydrogen molecules are stripped of their electrons. The electrons travel through this negative to the positive electrode, generating electricity, and then the protons will combine with oxygen to form water. You can see the same thing going on here. Why is it like a battery? Well, one of the things that I'm going to talk about in this lesson is what happens if I've got a solar panel or a wind turbine or something and I'm generating more electricity than I actually need. What do I do with that leftover electricity? Is it going to be wasted? Well, we want to store it. And we could store it in a battery, or we could store it by creating hydrogen fuel with it, using that energy to transform one material into another, into a fuel source, right? So we can transform it into hydrogen, which can then be used later. That's one of the advantages of hydrogen. Additionally, it's super lightweight. It produces no sound. It's not combustion, so the cars are totally silent. They're totally light in terms of their weight. They only produce water and heat. There's no air pollutants or greenhouse gases. Hydrogen is extremely abundant, and it can be synthesized in a plant or a lab. The recharge is instant. You don't have to recharge your car. The fuel works immediately. There are no moving parts. It's not a mechanical engine, so a car can't really break down. It's 65 to 90% efficient. So there are a lot of plus sides here. Downsides, one, hydrogen is extremely explosive. So that's a downside. The technology is new, it's not super well developed, and it's expensive. Additionally, because it's new, it's not a lot of infrastructure for it around the country. You don't see a lot of hydrogen refueling stations. Additionally, the production of hydrogen fuel is not exactly straightforward. It can be synthesized, but one method of doing so is combining steam with natural gas to create hydrogen. Unfortunately, a byproduct of that is CO2, which kind of defeats the purpose of having no emissions, right? Additionally, another method of doing that is the process called electrolysis, where you run an electric current through water to split it into hydrogen gas and oxygen gas. This is a pretty common process, and the issue with this is you're using electricity. Now, if you're getting your electricity from a solar panel, then that's totally renewable. But if the electricity you're using to generate this fuel is from a coal power plant, it's not exactly solving the issue of fossil fuel usage. The next option is wind energy. Wind power is harnessed by using the usage of a wind turbine. Wind turbines are like giant propellers or fans or pinwheels, massive, that when a wind flows through them, much like the wings of a plane, they will have lift and drag, and as a result they will spin. That mechanical energy is transferred to electric energy by turning a turbine, which then turns a generator. It's the fastest growing source of electricity in the world, and these things are massive. It's not a tiny little pinwheel that you get on a birthday party or something. They are massive. You can see these are some of the blades being transported to a building site, I would guess, in Europe. They can also be built offshore. And the reason they're done offshore is because the wind tends to be stronger and steadier offshore. It is a little bit more expensive to construct them, but overall they tend to be cheaper than land-based wind farms. Other advantages of wind include there's no carbon output, no greenhouse gas emissions, no air pollutions at all. They cost less to construct and run than fossil fuels. They create tons of jobs. The wind is completely renewable, and additionally, once you set these up, they're good for a very long time. You don't have to keep inputting fuel source like with a power plant. The wind just keeps on coming. The new technology, with every year, it gets cheaper, more efficient, and more quiet. It can be used on a large scale or a small scale, and you can use wind farms in conjunction with other types of land use. So you could have wind farms on a cow pasture. So you're using one piece of land to do two different things. Wind power is the fastest growing renewable job sector, but you can see other sorts of renewable energies are also generating lots of jobs. Additionally, they can be built at a really massive scale. Not only can you build wind farms like you see here, but you can also build just giant wind turbines. There's a brand new 13 megawatt turbine in late 2020, as of recording this video anyway, built in the Netherlands by GE. It can power a whole house for 2 days just by spinning once. It's 13 megawatts. It's 63% efficient. It can power tens of thousands of homes by running just for a day. It can power an entire home for running for 7 seconds. It's huge. It's comparable to the Eiffel Tower in terms of its size, bigger than the London Eye, although a bit smaller than the Empire State Building. So this thing can generate a ton of electricity, largest one in the world. You can build them big, but you can build them small too. I already talked about William Kwamba, who built a wind turbine for his village, and you can also build them medium size, like the Rosebud Sioux tribe in South Dakota, who is the first tribally owned windmill that powers 200 homes in their community and makes them about $15,000 in revenue per year. So wind turbines are very versatile in their size. Some of the downsides, however, they can kill migratory birds and bats when they collide with the wind turbines. They can be noisy, although they're getting quieter every day, and some people think they're unsightly. There's this whole phenomenon of not in my backyard. The reason why a wind farm hasn't been built off of Cape Cod or Martha's Vineyard, despite there being great wind potential, is that people don't want to see them. Personally, I think they look kind of cool. They're not good in all areas. You can't build them in a place that isn't windy, so you can only build them in places where there's lots of wind. And again, what do you do with extra energy? You need to find a way to store it, whether in a battery or as hydrogen fuel. You may have heard that they cause cancer. That is not true. There's no scientific evidence to back that up, so that's just totally false. When talking about the wind turbines and their killing of birds, if we look at this graph, we've got different causes of bird deaths with the amount of bird deaths per year, and you could see wind turbines barely even scratch the surface of bird deaths, somewhere between 100 and 600,000 bird deaths per year. Meanwhile, things like glass windows are killing up to 1 billion birds a year, and domestic cats can kill anywhere from 200 million to 3.7 billion with a B birds per year. So although wind turbines do kill birds, it's a bit of a straw man argument because there are things out there that really kill a lot more birds. If we're concerned about birds, we should be concerned about the cat population and not building wind turbines. So it's a bit of a straw man argument. Additionally, a recent study found that painting the wind turbine blades black reduces bird collisions and bird deaths by 70%, just because the contrast makes it easier for the birds to see. And birds suffer from air pollution from coal power plants just like humans do. And in fact, by replacing coal power plants with wind turbines, we'd probably be doing birds a favor in the long run. Excuse me. Oh, that air pollution's getting to me. Anyway, the last option I want to talk about is hydroelectricity, usage of water to generate electricity. The first way you probably think of to do this is the usage of a dam. You build a dam across river to collect water in a reservoir, and as the water flows through that dam, it'll turn a turbine. This is a beautiful picture of the Kerr Dam in Montana. I think they're marvels of humankind's engineering and ingenuity. Cool fact, in 1930, 3,123 dams were built across the United States. That's a lot of dams. So the way a dam works, right? You build a dam on a river, you've got a reservoir here with the water being held back by the dam, and there's a channel running through the dam with a turbine in it. As the water flows through that channel, it will turn that turbine, which is connected to a generator, which generates electricity, right? Obviously, the bigger the dam, the more electricity can be generated. Here's another diagram showing the same thing. Dams rely on impounding water behind the dam itself, building a reservoir. The largest reservoir is the Grand Coulee Dam in Washington here. And the largest dam itself is the Three Gorges Dam on the Yangtze River in China. This dam is massive. It's over 2 kilometers long. It took 40,000 workers 17 years to build and took $23 billion in funding. And it generates the electricity of 18 large coal power plants or 18 nuclear power plants. So lots of energy being produced. Unfortunately, it displaced 1.2 million people. It was built on a seismic fault and already has small cracks in it. And on top of that, it's susceptible to erosion, sedimentation, and flooding. Although this is a massive dam, dams can be built at a much smaller scale, kind of like wind turbines. Here's a hydroelectric plant in Monroe on the Housatonic River, and the Wallace Dam in Wallingford on the Quinnipiac River is also quite small. You can see on the side here this little cement thing. What that actually is a little channel they built on the side, so the water runs around through this channel, and that's where the electricity is generated. Inside that channel is a little bitty, itty-bitty turbine, and as the water flows through, it will generate electricity through that turbine. This is called run of the river, where you can redirect a small portion of the river to generate electricity rather than damming up the whole river. Hydroelectric has a lot of advantages. This is the Hoover Dam, the most famous dam in the United States. There's no pollution or waste or greenhouse gas emissions, I should say. The reservoirs can be used for drinking water or recreation. It has the highest energy return on investment compared to any other type of energy, and they can be built at small or large scales. Additionally, they can be used kind of like a battery through something called pump storage, where if you've got extra leftover energy, much like I mentioned before, you can use that energy to pump water uphill and store it. And when you need that energy later, you can release that water back downhill to turn a turbine. So they're kind of like massive batteries in a way. Disadvantages of dams are numerous, however. The construction is extremely expensive. Mixing cement, which dams are made of, produces CO2. Dams can collapse, doing substantial damage to downstream animal habitats, ecosystems, as well as human habitats. Siltation. Sediment can build up behind the dam over time, which can, especially if the dam collapses, increase turbidity in the water, make it difficult for organisms to breathe and filter out oxygen, makes them difficult to see, and it can also make it difficult to do photosynthesis. Dams can destroy or fragment habitat, specifically for fish like salmon, who swim upstream to lay their eggs and breed. Dams make it impossible for them to do that. Dams displace human communities, and by reducing the amount of water downstream, by damming it all up, that means that there is increased evaporation, which means that the temperature is going to be higher and might be outside the range of ecological tolerance for some organisms. Additionally, once you dam a waterway, you can't dam it again. So although dams are renewable, there are only so many rivers you can dam. Thankfully, there are solutions to some of these issues. One of the issues related to habitat fragmentation are these things called fish ladders, which is basically a wet set of stairs. Salmon who swim upstream can actually jump and swim up this thing, so that way they can get upstream to lay their eggs. Here is a summary of some of the pros in green and some of the cons in orange of dams. Dams can be removed. It's probably better not to build them in the first place, but if they're in danger of collapse, you can remove them. Additionally, it can help restore habitat and restore the fish runs. So there are a lot of benefits to dam removal. Unfortunately, there are some downsides as well. Oops, I've got a typo there. If you remove the dam, you're causing some rapid change to the ecosystem, and the populations may not be able to respond to that in time. You might change the flow of river, you might change the amount of sediment load. The sediment that's building up behind the dam could be contaminated with metals that have accumulated over time, heavy metals like mercury or lead or something. So you can do damage to downstream organisms by removing a dam. And the last thing I'm going to talk about is getting energy from the ocean. You might know who Frank Ocean is, but if you don't know who Billy Ocean is, you should go look him up on Spotify. Good stuff. So the ocean has lots of energy. Between waves and the tides, there is a ton of movement kinetic energy going on there that we can capitalize on. Hudson River fluctuates 15 feet daily in New York City. The Gulf Stream moves millions of gallons of water today. Long Island Sound has tides that go from 0 to 7 feet over the course of like 6 hours. So there's a lot of energy we can capture there. And it could be as simple as building a turbine underwater at the tidal levels that spin as the tide goes in and out. As you can see here, some pretty cool ideas. This one has got tidal turbines. It's got solar panels and a wind turbine all in one, so it's like the super renewable energy extravaganza, which is pretty cool. Additionally, you could build a tidal power station like this one in South Korea, whereas the tide goes in and out through this facility here. It actually passes through a channel with a turbine in it, kind of similar to a dam. And the water passes through, turns the turbine, and then when the tide goes out, passes through and turns the turbine. So that can actually generate a lot of electricity. You can also generate electricity by capitalizing on wave energy. This thing kind of moves back and forth with the waves and generates electricity. This is a buoy. As the waves go up and down, it kind of pumps up and down, which can generate electricity. They're a little bit more niche, but they're kind of cool. And the last one I want to talk about, I think, is pretty cool because it connects to a lot of things we've talked about. It's called ocean thermal energy conversion. The ocean has a thermal gradient. We know that. We've talked about that before. As you go down, it gets colder because the sunlight can't penetrate as well, so it's warmer at the top and colder at the bottom. And what you can do is you can harness that thermal gradient. Ammonia is a chemical that has a very low boiling point. So what you can do is you can have ammonia in a closed system and use the warm sea surface water to evaporate that ammonia. And that ammonia vapor will turn a turbine, which will generate electricity, and then you can pump up cold seawater to condense that ammonia vapor and reuse that and recirculate it. So here's a cool GIF showing how that works. You've got ammonia vapor in this closed system here, and you can evaporate it by pumping in warm seawater, evaporates the ammonia, goes through, it turns a turbine, which generates electricity. The ammonia is then condensed and cooled by the deep ocean water and is recycled and used up again. So this is ocean thermal energy conversion. I don't actually know how prominent it is, but I think it's pretty cool, and it has a lot to do with convection. And I mean, hey, who doesn't love convection? So you might be asking, all right, we talked about all these different options. Which one is the best? Spoiler alert, the answer is all of them. Ultimately, as a society, we're going to have to move forward in a direction that blends lots of different renewable energy sources together. We can't just rely on one. There's no magic bullet that's going to solve all our problems. We need to get creative, and we need to use a variety of different approaches. That being said, I expect that solar and energy will pick up the brunt of our energy demands as they become more efficient and more cheap as time goes on. So that's pretty much all I've got for you today. If you've got questions, bring them to class. Otherwise, I will see you then.